good day everyone. My topic for today is tap changing transformers and load ratio control. So we have two types of tap changing transformer. First is offload tap changing transformer and the other one is onload tap changing transformer. Offload tap changing transformer is you have to install in offload changer on a transformer if the required change in voltage is infrequent. The taps can be changed after completely isolating a transformer from the circuit. This kind of changer is generally installed on distribution transformer. The tap changing can be carried out when the transformer is in offload or no load condition. In a dry type transformer, the cooling phenomenon takes place mainly with natural air. Unlike in onload tap changing where the arc quenching is limited by oil when the transformer is in onload, the tapping with an offload tap changer is only carried out when the transformer is in off-switch condition. So mainly, ginagamit yung offload tap changing transformer is in off-switch condition. At ginagamit ang offload tap changer mainly in voltage when the voltage is infrequent or yung parang hindi balance yung voltage na kailangan na required nung isang transformer. Next, it is often utilized in situation where turn ratio doesn't need to be changed much and the energizing is allowed in low power and low voltage transformers. In some, tap changing may be done with a rotary or slider switch. It can be mainly seen in solar power projects. Offload tap changers are also used in high voltage transformers. The system of such transformers include a no-load tap changer on the primary winding. This changer helps accommodate variation with a narrow band around the nominal rating. In such systems, the tap changing will often be done only once at a time of installation. However, it can also be changed during a scheduled outage to address any long-term change in the system voltage profile. So mainly, yung offload tap changers daw po ay ginagamit ito sa mga high voltage transformer. Saka, at sabi dito, pwede siyang gamitin kapag may parang may outage o ng voltage or parang yung kulang na na supply ay maipoproduce niya. Parang siya yung magiging pamalit or siya yung magiging temporary na magbibigay ng sapat na voltage para may source pa din ng kuryente. So here's the image of offload tap changing transformer. So on the other hand, on load tap changing transformer, its primary feature is that during operation, the main circuit of the switch should not be opened. This means that no part of this switch should get the short circuit. Due to the expansion and interconnection of the power system, it becomes crucial to change the transformation taps numerous times every day for achieving the necessary voltage as per the load demand. This demand of continuous supply doesn't allow you to disconnect the transformer from the system for offload tap changing. Hence, onload tap changers are preferred in the majority of power transformers. So, sinasabi po dito na parang crucial itong onload tap changing na bawal siyang buksan during the operation and bawal din siya yung madaan sa pag-short circuit. Dahil nagiging crucial ito kasi yung mga itong onload tap changing hindi niya dito kailangan na alis-alisin siya kasi may maintain siya na dapat ma-achieve na voltage sa araw-araw. Unlike pag sa offload tap changing, pwede mo siyang maalis. Pero kadalasan ang onload tap changers, siya yung ginagamit sa majority ng power transformers. Yun yung kinaganda niya. So next, Ito po yung image ng tap changing transformer. So, the tap changing employing a center tap reactor are shown in the figure. Here, S is the diverter switch and 1, 2, and 3 are selector switch. So, ito yung reactor, yung R, ito yung S, at ito yung numbers 1, 2, 3 na magsisilbing selector. The transformer is in operation with switches 1 and S closed. To change to tap 2, switch S is open and 2 is closed. Switch 1 is then open and S closed to complete the tap change. Pinapakita po dito yung variation nila kung paano bubuksan, paano gagana yung on-load tap change yung transformer. So, it is to be noted that the diverter switch operates on load and no current flows in the selector switches during tap changing. During the tap change, only half of the reactance which limits the. It is to be noted that the diverter switches operates on load and no current flows in the selector switches during tap changing. During the tap change, only half of the reactance which limits the current is connected in the circuit. So, lipat naman po tayo sa another topic, load ratio control. Load ratio control of transformers, which means the possibility of changing the transformation ratio without interrupting the load. So, sinasabi po dito yung mainly, yung kinokontrol niya dito yung ratio ng load without interrupting. So, ibig sabihin, tuloy-tuloy siya habang may nababago dun sa ratio niya, yun sa pag-distribute niya. Has found very rapid adoption on account of its wide application possibility. It provides the long-sought solution for a voltage regulation on industrial loads and large blocks of power, and enables a perfect tie-in operation of two or more power systems with any desired load dispatch regardless of voltage or power factor. It is the only economical method known to extended transmission system on an equipotential basis. Maganda yung nung side nitong load ratio control kasi nagagamit siya sa sa mga large blocks of power. Tsaka kaya niyang mag-operate ng two or more power system with any desired load dispatch regardless of voltage or power factor. So, ginagamit siya kagaya ng sa mga substation, mga ganyan dito sa NGCP. Kasi madami siyang napuprovide na load kahit anong number nung need na load. So, sinasabi dito na it is only economical method known to operate extended transmission. So, ibig sabihin, na napaka-broad yung kaya niyang maabot na binibigay niyang load. Saka sinasabi dito na equipotential basis. So, sinabi na equipotential basis. So, ito yung, from the word itself, yung mga equipment na may kakayanan or mga possible na maging part ng transmission system na provide ng mga loads. So, the ratio of a transformer while under load can be varied by changing tap connection on either the high voltage or the low voltage winding. One objection to tap changing on the low voltage side is that in large size transformers, the ion voltage current becomes excessively high, thereby requiring a large and expensive copper cross-section for carrying the current. So, alam naman natin yung copper ay isang mamahalin din na equipment na magagamit. So, kaya parang yun yung risk sa kanya na magkukos siya ng madaming copper cross-section. In accordance with this invention, the load is divided into groups which, while using the same as different parts of their voltage range, never use the same taps at any one time. In this trait, the maximum currents and hence the copper areas are substantially decreased. This is especially practical in the case of electrical locomotives, in which there are usually a plurality of equal voltage traction motors which can conveniently divided into groups. Another feature of modern form of transmission utilizes single balancing transformer for increase the number of voltage steps for each load, and also either using switching duty or the top changers for each load. Substation equipped with automatic load ratio control equipment are frequently operated with their secondaries in parallel. The units may be physically together, the secondary tied together by a tile line or a group of tile lines as in primary network. At the present time, large number of factory-built distribution substations are being sold, and well over half of them are equipped for some form of network operation. As with most voltage regulators, automatic load ratio control equipment is usually controlled by means of a line drop compensator and a contact-making voltmeter. This automatic control equipment has two principal functions. First, it serves to maintain some specified voltage regulation at some point on the distribution system. Second, it serves to maintain regulator stability and to keep circulating currents at a minimum. So mainly, yung function niya dito, sinasabi talaga na siya yung nagre-regulate dito ng distribution ng load or ng voltage. Siya yung parang nagpo-provide nung equilibrium ng system. Siya yung parang utak nung system, kung paano magfo-flow, siya yung magdidictate, siya yung magko-control. Yung sa pangalawa naman, sinasabing serves to maintain regulator stability and to keep circulating currents at a minimum. So, siya din yung nagpro-provide nung kung ano ba yung dapat or yung sapat na currents na kailangan within the system. So, yun lamang po yung report ko about top changing transformer and load ratio control. Maraming salamat po. For my reference, ito po yung pinagkuhaan ko ng source. Thank you po.